Hello everyone, Mr. Geislart here, and we're going to take a look at question number 16 from your target packet. Okay, what we have here is we have a parallelogram and then we have a trapezoid that's on top of the parallelogram. What makes this bottom thing a parallelogram is that opposite sides are parallel. Now, I know we haven't talked about this before, but I'm going to just show you how to find the area of a parallelogram. The first thing I'm going to do is I just outlined the parallelogram itself, and I'm going to move it over here. So notice if you take the triangle that I have drawn here in blue, and if I move that to the other side, I've now created a rectangle. So I've gotten rid of this part over here, triangle, and I put these two together so that it's a rectangle. We know how to find the area of the rectangle is just the base times the height. So to find the area of the parallelogram, it's really just the same thing, the base times the height. These two marks mean that those are the same length. So if this whole side here is 20, that means that this side here is 10. So to find the area of the parallelogram, I would take 35 times 10, which is 350. Then I just need to find the area of the trapezoid that's on top. Because the lines are parallel, this side is the same length as this side. So this side up here is 35 as well. So I'm just going to use the formula for the area of a trapezoid, which is base 1 plus base 2 times the height divided by 2. And again, you may not have seen that before, so you can just kind of use that formula. So base 1 we have is 13, plus base 2 is 35, times the height, which is 10, divided by 2. So when you put all that in, you're going to end up with 240. So you have 350 and 240. Add those two together, and that should give you your answer.